Right, so this is our second video for graphing with the logarithmic functions. Before we get into the actual graphing component, I just want to give you some shortcuts for finding domain and vertical asymptote. So the key with that is you're going to be focusing in on the parentheses, because that's where the horizontal translation is coming in, and now we're switching over to a vertical asymptote, which is going to move it left and right. So if you take that inside parentheses and make it greater than 0, that's going to actually help you find the domain. So I would subtract 4, divide by 3. I'm going to show that because there's some special things that can happen. And I would get x is greater than -4/3, which you can leave it that way. You could also do -4/3, comma, infinity, if you like that option better. And then the only change for the asymptote, the number is the same, but the asymptote is equals -4/3. Same thing for number 2, except subtracting 5 isn't problematic. But when we divide by -2, we have to flip the inequality when you divide by a negative. It's an old rule that hopefully you do remember back from your pre-algebra algebra days. So this will become x is less than 5/2. And the asymptote itself is just setting it equal. And then for the domain, if you wanted to rewrite it in the interval notation, you can make it -infinity, comma 5/2. But I recommend just leaving it as the inequality. It's just easier and it gives the same result. All right, now for the next one, we'll talk again about the transformations. We'll use the calculator though to really help us with the graphing. One of the things that's important for the transformations is to rewrite it with the inside number factored out. So 2 times x minus 2, because that will give you the correct horizontal translation. So we have 4 transformations here. Reflect over the x-axis. We have a horizontal shrink by a factor of 1/2. Remember, horizontal stuff, that's coming from the 2 here. You always want to flip that over. So sometimes that actually just makes it look like it's getting taller, but it technically is a horizontal shrink. And then we have a translate right 2 and up 3. So we can either use our technique from above, or if we do factor it out, this would also give us the information we need for our vertical asymptote and our domain. So I can do the same thing I did up above and do 2x minus 4 is greater than 0 and solve that. Oops. So add the 4, divide by 2. That would give us x is greater than 2 and x equals 2 is the vertical asymptote. But if we just work with the transformations, because we're translating to the right 2 from here, that gives us our vertical asymptote at x equals 2. I again abbreviated VA as standing for vertical asymptote. And then domain, we actually already solved for the fact that the domain is x is greater than 2. Or you can do 2 comma infinity if you would rather do that notation. Now for critical points, this is where we'll pull our information from the calculator. I know I did the transformations on the first example. Before we do that, let's put in -infinity to infinity for the range. That will be consistent for all our logarithm graphs. All right, so let's go to the calculator. This is a little tricky, so you just have to follow along with me and make sure that you type this in correctly. We'll do negative. Now, instead of hitting the log button, which is next to 7, I'd rather do math. Now, you can scroll down or you can select letter A. Since you're not seeing it, it might be better to scroll down until you find log base. Hit enter. And then it brings up what you need. So I'll put in the 2 and the 2x minus 4 plus 3. So again, when you're looking for a log base, math, scroll all the way down and select A, log base. Make sure if there's a number in front, you've typed that in first though, because otherwise you'll end up having to overwrite it and that can get annoying. So we have everything we need. And this is really just to help us with getting our points. So we'll hit second graph. Notice we get a lot of error messages here. So my goal is just to get some good points that I'm able to plot. I can see I have 3, 2, 4, 1. I even have 5.42. And since I have that x-intercept 6, 0, I might as well plot that. As long as you have 3 points or more, that's good. Because it gives you the idea that we're getting closer to the asymptote and flattening out that direction and then going quickly away from the asymptote line the other direction. So same as the exponential function, but these are the inverse function, so they're going the opposite direction. All right, so it's important to understand that the reason why the graph is moving is because of these transformations. And in fact, if we go back to the front page and we look at the original graph, the reflection over the x-axis for this first graph, which is what we had here, would flip it going this way. And that's kind of what we're seeing, that opposite direction. So understanding that is important, but we are using the calculator to help us with that part. All right, last one. This is a little easier to type in. ln, remember, is log base e. It's the natural log. So same thing. I'm actually going to rewrite this first as 2 ln of negative x plus 1 minus 4. And then rewrite that one more time as 2 ln, factor out the negative, so it's x minus 1 minus 4. Now when you type it in, type in the original so you don't make any mistakes. But for transformations, we have vertical stretch by a factor of 2. And the outside number. The negative inside is a reflect over the y-axis. So that will actually bring our graph to the left instead of the right. And then we have a translate right 1 and down 4. Now, if you did not factor out that negative sign, you would have the incorrect horizontal translation. And then, like was stated before, this minus 1 in here, or the fact that we're going to the right one, gives you your vertical asymptote. So that's one way to find it, is from the transformation. Or if you want to do it like we did at the beginning, take the inside of your parentheses, negative x plus 1, set that to be greater than 0, subtract the 1, divide by negative 1. Remember, dividing by the negative flips the inequality. So we can also check that out from the graph, but x is less than 1. Remember, these should match up. And then our range is going from negative infinity to infinity always. Let's see if we can get some good points that we can plot. Maximum 3. All right, so let's jump over to the calculator. Let's plug that in. We have an ln button, so we don't have to worry about the log base. ln should either be right next to your 4 or right in between the 7 and the 4, depending on your calculator version. For me, on this calculator, it's It's kind of in between the 4 and the 7. I know the color version, it's going to be right next to the 4. So type that in, second graph, and let's look for some good values. So right next to the error message, I see some 3 values. I'm going to go with those. I'll do -2, -1.8, -1, -2.6, and then 0, -4. Just enough so that we can see what direction this is going. And you can see the points getting closer, so this is the side where it's going to flatten, and then the other way is the side where it's pulling away. All right, so that wraps up our second video for graphing logarithms. Key information for both is identifying where the asymptotes are, looking at the domain and range, and also just getting the general picture of the graph using points from your calculator.